Hi folks, this is Karim Raouf from the IT Visualizer channel. We will continue our lab, the Matrix Labs, the video number 16 we have been discussing in the previous video. The following, I have been working now for maybe 2 videos on or discussing the tool which called DCDIAG. This is a very important tool to troubleshoot domain controllers and Active Directory status or health. So this is a very important tool which is used by most of our administrators or system administrators to troubleshoot problems concerning the Active Directory. And we have seen or discussed what are the services that will be affected if the Active Directory is not working properly. So if you remember this graph, these are the systems dependent on Active Directory. I've discussed that group policy, for example, is dependent upon Active Directory, Windows Update, and all of these services are dependent on the Active Directory. So if there is a problem with the Active Directory, all of these services will be affected. Okay, so today we will make or we will we need the opposite of this term. So what are the services that will affect the Active Directory? So these services are affected or depend upon the Active Directory. What services Active Directory depend on? So this is a different question, and this is also very critical. So for example, if one of these services is not working properly, that means that the Active Directory is not working properly. So why the Active Directory is not working properly? Here we can see this graph says AD cannot function without these 4 important services. We will discuss today each of these services, what is the function of each of these services and its relation to the Active Directory. So by understanding the services that Active Directory depend on and the services that are dependent upon the Active Directory, we can have a complete vision on what will be the problems that will arise in our network if there is a problem with the Active Directory. So we can know that, for example, if the group policy is not working, then there is a problem with the Active Directory. If there is a problem with the Active Directory, then we need to check the services that the Active Directory cannot function without. So we will see and explain each one of these services one by one, but I need to focus on one service. In the previous video, we have talked about something called message queuing. This service is dependent upon the Active Directory. So I need to focus on this service a little bit because it has an interest or an interesting concept, the message queuing. So if the Active Directory is not working properly, the message queuing will not work. So let's focus on this service, and then we will go and discuss the services that Active Directory cannot function with. So let's go and see a little bit of description. What is message queuing? We have said before, this is a way that applications talk to each other in an Active Directory domain or within a domain. What is the way that applications talk to each other in a domain? Okay, they use message queuing. What is message queuing? Let me give you a little bit of illustration about what is message queuing and its relation to the Active Directory. Just wait for a moment.
Message queuing, MSMQ, in simple terms. What it is, message queuing, MSMQ, is like a postal service for computer programs. It allows programs to send messages to each other, even if the recipient is not immediately available. How it works. Queues. Imagine a mailbox where messages are stored until the recipient comes to pick them up. MSMQ uses these mailboxes called queues. Sending messages. When a program has something to say, a message, it drops it into a queue. Receiving messages. The receiving program checks the queue and picks up messages when it's ready. Why it's useful. Asynchronous communication. Programs don't have to wait for each other. They can send and receive messages at their convenience. Reliability. Messages don't get lost. MSMQ makes sure they stay safe in the queue until they are picked up. Scalability. It can handle lots of messages and keep things running smoothly even when there's a heavy load. Examples. Online orders. When you place an order online, the order details are sent to a queue. The order processing system picks them up and processes them when it's ready. Email systems. Emails can be sent to a queue and then delivered in batches to prevent the server from getting overloaded. Benefits: flexible timing. Programs can send and receive messages without needing to be active at the same time. Safe delivery ensures messages are delivered correctly, even if there are temporary issues. Administration: installing MSMQ. Set it up through the Windows Server Manager. Configuring queues. Set properties like size and security. Monitoring: keep an eye on queues to make sure everything is working smoothly. In essence, MSMQ is a handy tool that lets computer programs talk to each other safely and reliably without needing to be directly connected or active at the same time.
So this is a very, very good way uh, to programs talking to each other when there is a load on each application. So for example, application A wants to talk to application B, but there is currently a heavy load on application A. So it will send a message to a message queue or a mailbox, and then application B can go and get this message, okay, even though application B will have some traffic. So it's actually, as it said before, you don't need to have both programs set in front of each other to talk to each other directly. They can send or put the message in a mailbox, and then the recipient can get the message later. So this is one term. Let's go to Gemini and ask it the same question and see what is message queuing.
Imagine you work in a busy office with a lot of messages flying around. Sometimes, people might miss messages because they're on the phone, at lunch, or their computer is off. This can cause delays and confusion. Message queuing, MSMQ, in Windows Server is like a reliable message delivery system for your computer network. It acts like a central mailbox where applications can send and receive messages, even if the recipient isn't available at the exact moment. Here's how MSMQ helps. Reliable delivery. Think of it as a postal service for messages. MSMQ ensures messages are delivered safely, even if the recipient computer is temporarily unavailable. It holds the message in the queue until the recipient is ready to receive it. Asynchronous communication. Imagine two colleagues working on different schedules. MSMQ allows applications to send messages without waiting for a response immediately. The message goes into the queue, and the receiving application can pick it up later when it's ready. Flexible routing. Think of different departments in your office. MSMQ can route messages to specific destinations, whether they're on the same computer, across the network, or even over the internet. Here are some real-world examples of how MSMQ can be used. Order processing. An online store might use MSMQ to handle order confirmations. When a customer places an order, a message with the order details is sent to the order processing system, even if it's overloaded with other tasks. MSMQ queues the message until the system is ready to process it. Inventory management. A warehouse might use MSMQ to send alerts about low stock levels. These alerts can be queued and delivered to the purchasing department even if the purchasing manager is out of the office. Background tasks. An application might use MSMQ to send tasks for later processing. For example, a photo editing application might queue a resize job for a large image, allowing the user to continue working while the image is processed in the background. In short, MSMQ helps ensure smooth communication between applications on your network, even when things aren't working perfectly at the moment. It acts like a reliable message delivery system, making sure important information gets where it needs to go without delays or confusion.
Very, very good answer. We can see this is a very, very interesting concept on how messages or how communication is done between applications on different servers using the message queuing method. Okay, so this is a way, one way. There is other ways you can communicate, or programs can communicate with each other using something called RPC or remote protocol, something called RPC. We will discuss this protocol later. This is a direct communication, okay, not like a delayed communication like the message queuing method. Okay, so this is also a good method, and we have seen the situations when this type of messaging or communication between programs is needed in ordering items online, in email systems, in inventory management systems. So we can see this is also a very, very good example. Let's see Claude and see also the explanation of message queuing. Just a moment.
Sure, I'll explain message queuing service in Windows Server in simple terms. Imagine you have a group of friends and you want to send a message to one of them, but they're not available at the moment. Instead of calling them repeatedly or waiting for them to be available, you can write the message on a piece of paper and put it in a mailbox. When your friend becomes available, they can check the mailbox and retrieve the message. In a similar way, message queuing service in Windows Server acts as a mailbox for applications running on different computers or servers. When an application needs to send a message or data to another application, it can put the message in the message queue instead of trying to communicate directly. The receiving application can then check the message queue and retrieve the message when it's ready to process it. This mailbox-like system has several advantages. Reliability. If the receiving application is not running or is temporarily unavailable, the message is safely stored in the message queue until the application is ready to receive it. Asynchronous communication. The sending application doesn't have to wait for the receiving application to be available. It can simply put the message in the queue and continue with other tasks. Load balancing. Multiple applications can share the workload by retrieving messages from the same queue, distributing the processing among multiple servers or computers. Disconnected operations. Applications can send and receive messages even if they are not connected to the network at the same time, as long as they connect to the message queue at different times. Message queuing service in Windows Server provides a reliable and efficient way for applications to communicate with each other, even when they are running on different computers or servers, or when they are not available at the same time.
So this is very, very good explanation. Okay, let's go and ask ChatGPT for what is the relationship between this service and the Active Directory. So let's see again, by the way, this method will not work if the two programs are on the same server. So this will work if different programs are on different servers and they are trying to communicate to each other. Okay, so this is how message queue will work. It will work between applications on different servers. If two applications on the same server need to communicate, there is another way for communication. So let's go to the next question and ask ChatGPT 4 about the relationship between this service and the Active Directory. Let's go and see the answer in simple terms, of course. Just wait for a moment.
Relationship between MSMQ and Active Directory in simple terms. Active Directory, AD. Think of AD as a company directory that keeps track of all employees, their roles, and how they can be contacted. MSMQ and Active Directory. Public queues. Public queues are like public mailboxes where anyone in the company, network, can drop or pick up messages. Stored in AD. These public mailboxes, queues, are registered in AD, so everyone can find and use them easily. Security and authentication. Who can access? AD helps ensure that only authorized people can send or pick up messages from these mailboxes, queues. Verification. AD checks who you are before allowing access to the mailbox. Managing MSMQ. Central control. AD acts like a central control room, helping manage all the mailboxes, queues, and who can use them across the whole company, network. Reliability. Always available. AD makes sure information about the public mailboxes is always available, even if some parts of the network are down. In summary, AD registers public queues, makes them easy to find and use. AD provides security, ensures only the right people can access the queues. AD helps manage MSMQ, keeps everything organized and controlled. AD ensures reliability, keeps public queue information available all the time. This way, MSMQ uses Active Directory to make sure messaging between programs is secure, well-organized, and always accessible.
So this is very, very good answer. Let's go and see, just wait for a moment, guys. Let's go and see the answer of Gemini. If we go to Gemini and ask it the same question, what is the relationship between this service and the Active Directory?
Active Directory and Message Queuing, MSMQ, in Windows Server are like two different departments in a large company that work together to get things done. Active Directory, AD, is like the giant electronic filing cabinet for your network. It stores information about all the users, computers, and devices on the network, and also controls how they can access things. Imagine it as a central HR department that keeps track of everyone's roles and permissions. Message Queuing, MSMQ, is like a reliable message delivery service within the company. It acts like a central mailbox where applications can send and receive messages, even if the recipient isn't available at the exact moment. Now, how do these two departments work together? Optional integration. MSMQ can optionally integrate with Active Directory for some features, but it's not mandatory for MSMQ to function. Think of it as this. The message delivery service can operate independently, but sometimes it might need to check with HR for information. Security and permissions. If MSMQ is integrated with Active Directory, it can leverage the existing user and group permissions stored in AD. This can simplify managing who can send and receive messages through MSMQ. Imagine the message service using the HR department's access list to ensure only authorized personnel can send or receive sensitive messages. Efficient routing. With Active Directory integration, MSMQ can use network information stored in AD to route messages more efficiently. This can be helpful when messages need to be delivered across a large network or even over the internet. Think of the message service using the company directory, from HR, to find the most efficient route to deliver a message to the correct department. In summary, while MSMQ can function on its own, integrating it with Active Directory can provide additional security, permission management, and routing benefits for your network communication.
So we can see here the answer of Gemini. Let's go to Claude and see the answer. By the way, you need to check Gemini answers because sometimes it's not that accurate. So if one is working with MSMQ service, I think you need to check this answer anyway. So let's go and see the answer of Claude concerning this topic or concerning this question. Let's see the answer. But anyway, you can compare the answers.
Sure. I'll explain the relationship between the message queuing service and Active Directory in Windows Server using simple terms. Active Directory is like a central database or phone book that stores information about users, computers, and other resources in a network. It helps manage and organize these resources in a structured way. The message queuing service in Windows Server works with Active Directory to ensure that messages are delivered securely and reliably to the intended recipients. Here's how they work together. User identification. When an application sends a message to the message queue, the message queuing service checks with Active Directory to verify the identity of the user or computer that sent the message. This ensures that only authorized users or computers can send messages to the queue. Access control. Active Directory also stores information about which users or computers have permission to access specific message queues. The message queuing service checks with Active Directory to ensure that only authorized users or computers can receive messages from a particular queue. Message security. Active Directory can also provide security credentials, like digital certificates, that the message queuing service uses to encrypt messages before putting them in the queue. This ensures that the messages are secure and can only be read by the intended recipients. Directory services. The message queuing service can use Active Directory to locate and connect to other message queues or servers within the network, making it easier to route messages to the correct destinations. In simple terms, Active Directory acts like a trusted authority that the message queuing service relies on to verify identities, control access, provide security, and locate resources within the network. This collaboration between the two services ensures that messages are delivered securely and reliably to the right recipients, even in large and complex networks.
So we can see this is also a good answer. Let's go to, to the last thing to provide us with uh, some examples. We need to have real world examples to see, just a moment, real world examples to see how this will work. So before that, there is a question here. I asked him, what kind of messages does message queuing handle? So the messages or the applications talking to each other and sending messages, what are these type of messages? So let's see the answer of ChatGPT concerning this question.
Types of messages MSMQ handles in simple terms. Text messages, simple written messages like emails or short notes, binary messages, data in a computer-readable format like images, files, or any other non-text data, XML messages, structured data formatted in XML, which is like a recipe with specific tags to organize information, serialized objects, complex data turned into a simple format for easy sending, which can be reassembled back into its original form. Encrypted messages, messages that are coded for security, so only the intended recipient can read them. Transactional messages, messages that are part of a larger process, ensuring that all steps of the process are completed correctly or none at all, like making sure all items in an online order are processed together. In summary, MSMQ can handle many types of messages: simple text, computer data, structured information, secure messages, and messages that are part of bigger processes. This makes it useful for many different tasks and applications.
Very, very good answer. So we know the way of the communication, how MSQ communicate or help the communication between the programs or different programs on different servers. What are the type of messages sent between the applications? Uh, I think here I asked Gemini the same question, or I'm going to another one. Okay, yes, I asked ChatGPT only concerning this type of data. Let's see if I ask it Claude the same question here, or we are going to real world examples. Okay, so now we can ask ChatGPT about real world examples. So now we have everything cleared. Now we need to see real world examples concerning the MSQ. Let me think, or let me see something here. Here I am asking him to give real world examples related to the Active Directory. So if you didn't put this section related to Active Directory, it will give you MSQ or MSMQ examples not related to the Active Directory. So we need specifically this kind of real world examples. So let's see these examples. Just wait for a moment. Sorry, again, this answer is not correct. Just wait. I think here is the real, or here is the term that will be said. So let's wait here. Wait for a moment. Let me see. Okay, here is the answer, or here is the question. I need examples of SQ and their relationship to the Active Directory. Okay, uh, using real world examples. So I need the relationship between MSMQ and the Active Directory using real world examples. So here is the real world examples that show how MSMQ and Active Directory work together. Just wait for a moment.
Example 1. E-commerce order processing system. Scenario. An online store processes orders and updates inventory across multiple servers. Order placement. A customer places an order, and the order details are sent as a message to a public queue managed by MSMQ. The public queue is registered in Active Directory, making it accessible to different services across the network. Inventory update. The inventory management system, running on a different server, retrieves messages from the public queue. Active Directory ensures the inventory management system has the necessary permissions to access the queue. The system updates the inventory based on the order details. Order confirmation. Once the order is processed, a confirmation message is sent to another queue. The customer service application retrieves the message from this queue to notify the customer. AD helps manage access control and ensures that only authorized applications can interact with these queues. Example 2. Distributed banking application. Scenario. A bank uses MSMQ for secure, reliable transaction processing across different branches. Transaction initiation. A customer initiates a money transfer at a local branch. The transaction details are sent as a message to a public queue managed by MSMQ. This queue is listed in Active Directory, making it accessible to the bank's central processing system. Transaction processing. The central processing system retrieves messages from the queue to process the transactions. Active Directory ensures that only the authorized central processing system can access and process the transaction messages. If the central processing system is temporarily offline, the messages remain in the queue, ensuring they are not lost. Audit and logging. The bank's audit system retrieves transaction logs from another queue. AD controls access to this queue, ensuring that only authorized audit personnel can access sensitive transaction data. Example 3. Hospital Information System. Scenario. A hospital uses MSMQ for communication between different departments, e.g., emergency, pharmacy, billing, patient admission. When a patient is admitted, their information is sent as a message to a public queue. This public queue is registered in Active Directory, ensuring that different hospital departments can access it as needed. Pharmacy notification. The pharmacy system retrieves messages from the queue to prepare medication orders. AD ensures the pharmacy system has the right permissions to access patient information from the queue. Billing department. Once the treatment is complete, the billing department retrieves messages from another queue to generate the patient's bill. Active Directory manages access control, ensuring only authorized billing personnel can access these messages. Example 4. Logistics and supply chain management. Scenario. A logistics company uses MSMQ to manage package tracking and delivery updates across different locations. Package tracking. When a package is scanned at a warehouse, the scan details are sent as a message to a public queue. The public queue is managed by MSMQ and registered in Active Directory, allowing access from various locations. Delivery update. Delivery trucks retrieve messages from the queue to get updated tracking information. Active Directory ensures that only authorized delivery systems can access the queue. Customer notification. The customer service system retrieves messages from another queue to notify customers about the status of their packages. AD manages permissions to ensure that customer data is securely accessed only by the customer service system. Summary. E-commerce. Orders and inventory updates are processed reliably with MSMQ, while AD manages access and permissions. Banking. Transactions are securely processed with MSMQ, with AD ensuring authorized access. Hospital. Patient information flows between departments using MSMQ, with AD controlling access. Logistics. Package tracking and delivery updates use MSMQ, with AD managing who can access the information. These examples show how MSMQ and Active Directory work together to ensure secure, reliable, and efficient message handling in real-world scenarios.
So we can see very good example. I think I need to check and see if this service may be running on my PC, if it is working in the services. Let's see if we can have this kind of service here, or it is only on servers. So let's see message queuing. Okay, I think here we don't have only message service. Okay, here messaging service, uh, service support text messaging and related. I think this is related to text messaging between users, not between applications. So this is called Microsoft messaging queue. Okay, so I think this will be on servers or need to be installed. Okay, so this is one thing. So this is a good example on how message queuing and Active Directory are related. So let's see also this example or Gemini answer about this or the same question.
Imagine a large hospital with a busy network. Two key services help things run smoothly. Human Resources, HR. This acts like Active Directory. HR keeps track of all the staff, users, their departments, groups, and their access levels, permissions, within the hospital. They issue ID badges, usernames and passwords, that grant access to different areas, network resources. Internal Mail Service. This acts like message queuing, MSMQ. It delivers messages, data, between different departments, applications, even if the recipient isn't immediately available. They have a central mailroom, message queue, where messages are sorted and held until someone from the receiving department, application, can pick them up. Now, how can HR and the internal mail service work together? Active Directory and MSMQ integration. Scenario 1. Basic delivery, no integration. A nurse, application, needs to send test results, data message, to the lab, another application, urgently. The nurse uses the internal mail service, MSMQ, to send the message. MSMQ can function independently and deliver the message to the lab's mailbox, message queue, even if the lab technicians are busy with other tasks. Scenario 2. Enhanced security with integration. Suppose the test results contain sensitive patient information. With Active Directory integration, MSMQ can leverage HR's access control. The nurse's ID badge, username and password, is verified by HR, Active Directory, before allowing them to send the message. Only authorized personnel with the appropriate access level, lab technicians, can retrieve the message from the queue, ensuring extra security for sensitive data. Scenario 3. Efficient routing. The hospital has multiple labs across different buildings. With Active Directory integration, MSMQ can use the network information stored in HR, location data for labs. This allows MSMQ to route the test results directly to the most appropriate lab, saving time and ensuring it reaches the right technicians quickly. In essence, while MSMQ can operate independently for basic message delivery, integrating it with Active Directory offers additional benefits. Security. Active Directory acts like an extra layer of security by controlling who can send and receive sensitive messages. Permission management. HR's access control simplifies managing message access based on user roles. Efficient routing. Active Directory's network information helps MSMQ route messages efficiently across the hospital network. By working together, Active Directory and message queuing ensures smooth and secure communication within the hospital network, just like HR and the internal mail service keep things running efficiently in the real world.
So here this is another answer, and if we need to check the answer of Gemini, let me ask another AI tool to check the answer. So I need to ask Microsoft Copilot to verify this answer to make sure that Gemini is giving me the correct answer. Verify if this answer is correct. Is there any inaccurate info? In this text? Okay, anyway, I think the answer is correct. So let's go and ask Claude the same answer or the same question. Just wait for a moment.
Sure. Let me explain the relationship between the message queuing service and Active Directory in Windows Server using real-world examples. Imagine a large company with multiple departments and branch offices. The company uses Active Directory to manage and organize all its employees, computers, and other resources across the organization. Payroll processing. The payroll department at the company's headquarters needs to send out payroll information to all the branch offices every month. Instead of trying to connect directly to each branch office's computer system, which may not always be available, the payroll application can send the payroll data to a message queue. The message queuing service checks with Active Directory to verify that the payroll application is authorized to send messages to that particular queue. It also uses Active Directory to locate the correct message queues for each branch office. When the branch office computers are available and ready to process the payroll data, they can retrieve the messages from their respective message queues. The message queuing service checks with Active Directory to ensure that only authorized computers or users at the branch offices can access the payroll data in the queue. Order processing. A retail company with an online store receives orders from customers all over the world. When a customer places an order, the web application sends the order details to a message queue. The message queuing service uses Active Directory to verify the identity of the web application and ensure that it is authorized to send messages to that particular queue. The order processing department has multiple servers that retrieve orders from the same message queue. The message queuing service checks with Active Directory to ensure that only these authorized servers can access the order messages in the queue. Email delivery. A university's email server needs to deliver emails to thousands of students and faculty members. When an email is sent, the email server puts the message in a message queue. The message queuing service uses Active Directory to look up the email addresses of the intended recipients and locate the correct message queues for their respective email clients or servers. When a student or faculty member's email client is online and ready to receive messages, it can retrieve the email from its designated message queue. The message queuing service checks with Active Directory to verify that the email client is authorized to access messages in that particular queue. In all these examples, the message queuing service relies on Active Directory to ensure secure and reliable message delivery by verifying identities, controlling access, providing security credentials, and locating resources within the network.
A very, very good answer. Now, uh, we have discussed the message queuing and its relationship to the Active Directory. Okay, so now we need to begin uh, uh, our discussion today, which is these services AD cannot function without it. So we need to discuss this concept today. We have discussed this message queuing and it's dependent on the Active Directory. We need to focus on our uh, series or in our topic today. What are the services that AD cannot function with? And we need to explain it one by one. So let's go and begin our series. Just wait for a moment. Let me just prepare myself. Okay, so here we can go to ChatGPT and ask it this question. Okay, Active Directory cannot operate without LDAP and DNS and RPC and Kerberos. Explain each in layman's terms. So let's see the answer of ChatGPT 4.0.
Sure. ANAs. Let's explain LDAP, DNS, RPC, and Kerberos in layman's terms, highlighting their roles in Active Directory. 1. LDAP, Lightweight Directory Access Protocol. Explanation. LDAP is like a directory service for looking up information in a network. It's the system that Active Directory uses to organize and access data about users, computers, and other resources. Layman's terms, imagine LDAP as a giant phone book for a large organization. Just like you can look up a person's phone number and address in a phone book, LDAP lets you look up information about users and devices in a network. 2. DNS, Domain Name System. Explanation. DNS translates human-friendly domain names into IP addresses that computers use to identify each other on the network. Layman's terms, think of DNS as the Internet's phone book. When you type a website address like www.example.com, DNS looks up the corresponding IP address so your computer can find and connect to the website. Role in Active Directory. Active Directory relies on DNS to locate services and resources within the network. For example, when a user logs in, DNS helps the computer find the domain controller that verifies the user's credentials. 3. RPC, Remote Procedure Call. Explanation. RPC allows programs to communicate with each other over a network, enabling them to request services from remote systems. Layman's terms, imagine RPC as a way for one computer to call another computer and ask it to perform a task, like placing a phone call to ask a friend to do something for you. RPC allows this communication to happen smoothly over the network. Role in Active Directory. Active Directory uses RPC to enable different servers and services to communicate and work together. For instance, when you make changes to a user account, RPC helps ensure those changes are updated across the network. 4. Kerberos. Explanation. Kerberos is a security protocol that authenticates users and computers in a network, ensuring secure access to resources. Layman's terms, think of Kerberos as a bouncer at a club who checks IDs at the door. If your ID is valid, you get a ticket in Kerberos terms, that lets you access different areas of the club without being checked again. Role in Active Directory. In Active Directory, Kerberos authenticates users when they log in and issues tickets that allow them to access network resources securely and efficiently without needing to log in again each time they access a new resource. Summary. LDAP acts like a giant phone book for looking up information in a network. DNS works like the Internet's phone book, translating domain names into IP addresses. RPC enables computers to request services from each other, like making a phone call to ask for a task. Kerberos functions as a bouncer, authenticating users and giving them tickets to access network resources securely. These components are essential for Active Directory to operate, ensuring that data is organized, resources are located, services communicate, and users are authenticated securely.
Okay, very, very good answer. We can see here the relationship between all of these protocols and the Active Directory. Let's go and ask uh, Gemini to explain this relationship again using layman terms.
Active Directory is like a giant address book and control center for your computer network. But to function properly, it relies on a few key technologies working together, like a team with different specialties. LDAP, Lightweight Directory Access Protocol, imagine this as the phone book for Active Directory. LDAP lets users and devices find information stored in Active Directory, like usernames, groups, and computer details. It's how things look up contact information within the network. DNS, Domain Name System, this acts like a translator for Active Directory. Computers communicate using numbers, IP addresses, but humans remember names, like Server 1 or Printer 2. DNS translates these names into IP addresses so devices can find each other on the network. It's like using a phone directory to find a phone number based on a name. RPC, Remote Procedure Call, think of RPC as the delivery person for Active Directory. When a device needs to make changes or access information in Active Directory, RPC delivers those requests and brings back the responses. It's the messenger carrying instructions and information back and forth. Kerberos, this acts like a secure login system for Active Directory. When a user or device logs in, Kerberos authenticates them using a series of encrypted tickets. Imagine Kerberos as a high-security key system that grants access only to authorized users. Here's how they work together. 1. A user tries to log in to a computer, client. 2. The client uses LDAP to find the domain controller, server with Active Directory, in the network. 3. DNS translates the domain controller's name into an IP address so the client can connect. 4. The client uses RPC to send a login request to the domain controller. 5. Kerberos steps in and securely authenticates the user by verifying their username and password. 6. If everything checks out, the domain controller grants access to the user based on information stored in Active Directory. Without any of these technologies, Active Directory wouldn't be able to function properly. They all work together to ensure secure communication, find information, and ultimately, control access within your network.
A good answer. I see this is more or better than ChatGPT 4o because it relates every services or all of the services to the Active Directory in step-by-step instructions. So we can see the user's login, then he tries to find information using the LDAP on the domain controller, then he tries to communicate with the domain controller using the DNS, then sending the request to the domain controller using RPC. So this is a very, very good example. Let's see Claude, the answer of Claude concerning this issue or concerning the same question.
Sure, I can explain these concepts in layman's terms. LDAP, Lightweight Directory Access Protocol LDAP, is like a huge electronic phone book or directory that stores information about users, computers, and other resources in a network. It allows administrators to quickly find and access this information from a central location. Just like you would use a phone book to look up someone's phone number, LDAP is used to look up information about network resources. DNS, Domain Name System DNS, is like a phone book for the internet. It translates human-readable domain names, e.g., www.example.com, into numerical IP addresses that computers can understand. Without DNS, you would have to remember long strings of numbers, IP addresses, to access websites or other internet resources. RPC, Remote Procedure Call RPC, is a way for different software programs or components to communicate and share information with each other, even if they are running on different computers or servers. It's like two people using walkie-talkies to talk to each other from different locations. Kerberos. Kerberos is a secure authentication system used in Active Directory. It's like a secure badge system that verifies your identity and grants you access to resources on the network. When you log into your computer, Kerberos checks your credentials, username and password, and issues you a ticket that proves you are who you say you are. This ticket is then used to access other resources on the network without having to re-enter your password each time. In summary, Active Directory relies on these technologies to function properly. LDAP is the directory that stores information about network resources. DNS translates human-readable names into IP addresses for locating resources on the network. RPC allows different components of Active Directory to communicate and share information with each other. Kerberos is the authentication system that verifies user identities and grants access to resources in a secure manner. Together, these technologies enable Active Directory to manage and secure user accounts, computers, and network resources efficiently and effectively across an organization.
So I see the better answer or the best answer is for Gemini. Let's ask ChatGPT for the same question, but not using layman terms, using in a question and answer format. Explain why Active Directory cannot operate without LDAP and DNS and RPC using a question and answer format. So let's wait and see the answer.
Sure, ANAs. Here's an explanation of LDAP, DNS, RPC, and Kerberos in a 1. LDAP, Lightweight Directory Access Protocol. What is LDAP? A. LDAP is a directory service protocol used to look up information in a network. Question: how does LDAP work in layman's terms? A. Think of LDAP as a giant phone book for an organization. It allows you to look up information about users, computers, and other resources, just like you would look up a person's phone number and address in a phone book. Question: why is LDAP important for Active Directory? Active Directory uses LDAP to organize and access data about all the resources in a network, such as users, computers, and printers. 2. DNS, Domain Name System. Question: what is DNS? DNS translates human-friendly domain names into IP addresses that computers use to identify each other on the network. Question: how does DNS work in layman's terms? A. DNS works like the Internet's phone book. When you type a website address like www.example.com, DNS looks up the corresponding IP address so your computer can find and connect to the website. Question: why is DNS important for Active Directory? Active Directory relies on DNS to locate services and resources within the network. For example, when a user logs in, DNS helps the computer find the domain controller that verifies the user's credentials. 3. RPC, Remote Procedure Call. Question: what is RPC? A. RPC is a protocol that allows programs to communicate with each other over a network and request services from remote systems. Question: how does RPC work in layman's terms? Imagine RPC as a way for one computer to call another computer and ask it to perform a task, like making a phone call to ask a friend to do something for you. Question: why is RPC important for Active Directory? Active Directory uses RPC to enable different servers and services to communicate and work together. For instance, when you make changes to a user account, RPC helps ensure those changes are updated across the network. 4. Kerberos. Question: what is Kerberos? A. Kerberos is a security protocol that authenticates users and computers in a network, ensuring secure access to resources. Question: how does Kerberos work in layman's terms? Think of Kerberos as a bouncer at a club who checks IDs at the door. If your ID is valid, you get a ticket in Kerberos terms, that lets you access different areas of the club without being checked again. Question: why is Kerberos important for Active Directory? A. In Active Directory, Kerberos authenticates users when they log in and issues tickets that allow them to access network resources securely and efficiently without needing to log in again each time they access a new resource. Summary: LDAP acts like a giant phone book for looking up information in a network, organizing and accessing data about resources. DNS works like the Internet's phone book, translating domain names into IP addresses and helping locate network services and resources. RPC enables computers to request services from each other, facilitating communication and updates across the network. Kerberos functions as a bouncer, authenticating users and giving them tickets to securely access network resources. These components are essential for Active Directory to operate, ensuring that data is organized, resources are located, services communicate, and users are authenticated securely. Active Directory cannot operate without LDAP and DNS and RPC and
So now we can see by the question and answer format, now it is clear the relationship between these services and the Active Directory and why the Active Directory cannot communicate or cannot work without these services. So let's go and see Gemini answer concerning the same question in a Q&A format, or to ask him the same question, why Active Directory cannot operate without LDAP and DNS and RPC. Explain using Q&A format.
Active Directory's essential partners, Q&A. Q. Active Directory seems crucial, but why can't it work alone? What are these other technologies it relies on? You're right. Active Directory is like a powerful control center, but it needs a team to function effectively. These essential partners include LDAP, Lightweight Directory Access Protocol. Think of this as the phone book for Active Directory. DNS, Domain Name System. Imagine this as a translator for Active Directory. RPC, Remote Procedure Call. Think of this as the delivery person for Active Directory. Kerberos. Imagine this as a secure login system for Active Directory. Q. So, what exactly does LDAP do? LDAP lets users and devices find information stored in Active Directory. It's like searching a phone book to find usernames, groups, and computer details within the network. Q. Why is DNS important for Active Directory? Computers communicate using numbers, IP addresses, but humans remember names, like Server 1 or Printer 2. DNS translates these names into IP addresses so devices can find each other on the network. It's like using a directory to find a phone number based on a name. Q. What's the role of RPC in Active Directory? Think of RPC as the delivery person for Active Directory. When a device needs to make changes or access information in Active Directory, RPC delivers those requests and brings back the responses. It's the messenger carrying instructions and information back and forth. Q. How does Kerberos help Active Directory? Kerberos acts like a secure login system for Active Directory. When a user or device logs in, Kerberos authenticates them using a series of encrypted tickets. Imagine Kerberos as a high-security key system that grants access only to authorized users.
So you can see very, very good answer. If you go to Claude, he will repeat the same question. Okay, what is LDAP? All of his or this answer is repeated. Just the previous answers was without questions, so this answer is repeated from before, and the same answer as ChatGPT 4 and Gemini. So I will not list it, or I will not read it loudly. Let's go to the last thing to give us real-world examples on how Active Directory cannot operate without LDAP, DNS, and RPC and Kerberos. Let's see the answer of ChatGPT 4.0.
Sure. ANAs. Here are real-world examples to explain LDAP, DNS, RPC, and Kerberos and their roles in Active Directory. 1. LDAP, Lightweight Directory Access Protocol. Example. Scenario. Imagine you work in a large corporate office with hundreds of employees. Explanation. LDAP is like the Office directory. When you need to find contact information for a colleague, you look them up in the directory. Similarly, LDAP allows the network to look up information about users, computers, and other resources in Active Directory. Real-world impact. When you log into your computer, the network uses LDAP to quickly find your user account details and verify your identity. This ensures you have access to the files and applications you need. 2. DNS, Domain Name System. Example. Scenario. You want to visit a colleague's personal website. Explanation. DNS works like an internet phone book. You type in the website address, like www.colleaguewebsite.com, and DNS translates that address into an IP address that your computer can use to find the website. Real-world impact. Within an office network, DNS helps your computer find the correct servers and services. For example, when you need to log in, DNS helps your computer locate the domain controller that verifies your login credentials. 3. RPC, Remote Procedure Call. Example. Scenario. You need to request some data from a coworker's computer in another department. Explanation. RPC is like making a phone call to ask your coworker to perform a task. Your computer sends a request to another computer on the network, asking it to execute a specific action or provide some data. Real-world impact. In a company, if you update your user profile, RPC helps ensure that the changes are communicated and reflected across all relevant systems. This seamless communication keeps everything in sync. 4. Kerberos. Example. Scenario. You need to enter a secure area in your office building. Explanation. Kerberos acts like the security guard at the entrance. When you show your ID, login credentials, the guard verifies it and gives you a pass, a ticket in Kerberos terms, that allows you to access different parts of the building without being checked again. Real-world impact. When you log into your computer in an office network, Kerberos verifies your identity and issues a ticket. This ticket allows you to access email, shared files, and other network resources without needing to log in again for each service. Summary of real-world examples. LDAP, like the Office directory, helping the network look up user and resource information. DNS, like an internet phone book, translating website addresses into IP addresses so your computer can find the correct servers. RPC, like making a phone call to request data or actions from another computer in the network. Kerberos, like a security guard verifying your identity and giving you a pass to access different parts of the office. These examples illustrate how LDAP, DNS, RPC, and Kerberos work together to ensure Active Directory functions smoothly, providing organized data access, locating resources, facilitating communication, and securing user authentication.
So this is a very, very good answer. And now we have real world examples. Let's see the answer of Gemini and see its answer. I think I didn't like the answer of Gemini. It was not that good. So I will not read it because actually it's not illustrating something, or we have seen this before. Anyway, I think we can shell the large office, LDAP, the same accounting, remote procedure call, Kerberos. Uh, anyway, I think this answer will not help us much. So let's see the answer of Claude.
Sure, here are some real-world examples to explain LDAP, DNS, RPC, and Kerberos in the context of Active Directory. LDAP, Lightweight Directory Access Protocol in a large corporation with thousands of employees, IT administrators use LDAP to store and manage information about user accounts, computers, printers, and other resources in the Active Directory. When an employee needs to access a network resource, such as a shared folder or application, the LDAP directory is queried to verify their permissions and access rights. DNS, Domain Name System. Imagine a company called Example Corp with an Active Directory domain named examplecorp.com. DNS is used to translate the human-readable domain name, examplecorp.com, into an IP address that computers can understand. This IP address is used by client computers and servers to locate and communicate with the Active Directory domain controllers. RPC, Remote Procedure Call. When you log in to your work computer, which is part of the Active Directory domain, your computer needs to communicate with the domain controller to authenticate your credentials. RPC enables this communication by allowing your computer to call functions and procedures on the domain controller over the network, as if they were running locally. Kerberos. In a university setting, students and faculty use Kerberos authentication to access various resources on the campus network, such as file servers, email, and learning management systems. When you log in to your university account, Kerberos verifies your username and password and issues you a ticket that proves your identity. This ticket is then used to access other resources without having to re-enter your credentials each time, making it convenient and secure. Overall, these technologies work together to enable Active Directory to function seamlessly. LDAP stores and organizes information about network resources and user accounts. DNS translates domain names into IP addresses, allowing computers to locate and connect to Active Directory services. RPC enables communication between client computers and Active Directory servers for tasks like authentication and resource access. Kerberos provides secure authentication and access control, ensuring that only authorized users can access resources within the Active Directory environment. Without these technologies working together, Active Directory would not be able to efficiently manage and secure user accounts, computers, and network resources across an organization.
So you can see very, very good answer. Now we have all, or we have a complete vision about why the Active Directory cannot work without LDAP, DNS, RPC, and Kerberos using different answers from different AI tools. So I have a couple of questions here. I asked Chat GPT because actually there was a lot of things here that was not clear in my mind. So let me show you all the couple of answers that I have asked ChatGPT. Let me remember where was my answer. Just wait for a moment. So here I think it was, just wait for a moment. Here we can go. I think LDAP relationship maybe. Just wait, no, not this one. So we can go further. Okay, I think I have one thing here. Just wait for a moment. I think maybe this one. I think yes. Just wait for a moment. Okay, so let's go here. And there is a couple of questions I have asked ChatGPT here. So for example, I am confused between LDAP and Active Directory. Are they the same? Explain in simple terms. Let me see if I can read it loudly here. Just wait for a moment.
LDAP and Active Directory are related, but they are not the same. Here's a simple explanation of each and how they are related. At LDAP, Lightweight Directory Access Protocol. What it is, LDAP is a protocol, which means it's a set of rules that allows computers to communicate with directory services. What it does, it helps applications to find and manage information stored in directories, such as user details, passwords, and permissions. Example, when you log into a company's network, LDAP helps check your username and password against the directory. Active Directory D. What it is, Active Directory is a directory service created by Microsoft. What it does, it stores information about users, computers, and other resources in a network. It helps manage permissions and access to network resources. Example, Active Directory stores all the user accounts and passwords for a company's network, controls who can access different parts of the network, and helps manage network resources like printers and file shares. How they are related. Active Directory uses LDAP. Active Directory uses LDAP as one of the protocols to access and manage the directory information. When you interact with Active Directory, like logging in or searching for a user, it often uses LDAP to handle these tasks. Summary. LDAP Plus, a protocol for accessing and managing directory information. Think of it as a language that allows computers to talk to directory services. Active Directory. A directory service from Microsoft that stores and organizes information about users and resources in a network. It uses LDAP to handle some of its functions. So LDAP is a method for accessing directory information, and Active Directory is a specific directory service that uses LDAP among other protocols.
So very good example. LDAP, it is the protocol to access the Active Directory. Okay. So one question also arises: why we represent Kerberos as three-headed dog? Why is that? Actually, there is a reason behind this logo. So let's see what is the answer of ChatGPT.
The Kerberos logo, which features a three-headed dog, is inspired by Greek mythology. Here's a simple explanation. Origin of the symbol. Greek mythology. Cerberus, Kerberos in Greek. In Greek mythology, Cerberus is a three-headed dog that guards the entrance to the underworld, preventing the dead from leaving and the living from entering. Representation in Kerberos, the authentication system. Why a three-headed dog? The Kerberos authentication system uses the three-headed dog symbol to represent its three main components, which work together to protect network security. The three components. 1. Client, the user or application requesting access to a service. 2. Authentication server AS, verifies the identity of the client and issues a ticket. 3. Ticket granting server, TGS, issues service tickets based on the initial ticket from the authentication server, allowing access to the requested service. Summary. The three heads of the dog symbolize the three key parts of the Kerberos authentication process: the client, the authentication server, and the ticket granting server. Just like Cerberus guards the underworld, Kerberos guards access to network resources, ensuring that only authenticated users can access services. In simple terms, the three-headed dog logo for Kerberos represents its three-part security system, inspired by the mythical guardian Cerberus.
Okay, this is an answer. Let's go to the answer of Gemini. Uh, if we go further down, let me go and see the last answer. Here it goes. This is the answer.
Kerberos logo with 3 dog heads actually comes from Greek mythology. Here's the connection. Kerberos in myth. In Greek mythology, Kerberos is a giant, 3-headed guard dog who watches over the underworld entrance. He prevents the dead from leaving and the living from entering without permission. Kerberos in security. The Kerberos security system in Active Directory is similar to the mythological Kerberos. It acts as a powerful guard dog for your computer network. Its 3 heads represent different security features that work together to control access. 1. Authentication. This verifies a user's identity, like checking someone's ID at the entrance. 2. Authorization. This determines what a user is allowed to do, like granting access to specific areas in the network. 3. Encryption. This scrambles data like messages, ensuring only authorized users can understand them. Just like the 3-headed dog guarded the underworld entrance, Kerberos with its 3 security features protects your network from unauthorized access and data breaches. It ensures only authorized users can enter and access what they're allowed to see, keeping your network resources secure.
I think this answer is not correct because ChatGPT, I think this is the most accurate answer, but let me ask ChatGPT or Microsoft Copilot to verify this answer. Just wait for a moment. I think we need to initiate a new answer. Okay, I think here it is hanged somehow, but anyway, I think this answer is not correct, guys, so I will not depend on it. Let's go to Claude and see the answer because I think it will be more. Just wait for a moment. So guys, I need I need you to depend upon ChatGPT for answer.
The 3-headed dog logo associated with Kerberos has its roots in Greek mythology, and it represents the key principles and functionalities of the Kerberos authentication system in a symbolic way. Here's an explanation in simple terms. In Greek mythology, Cerberus, or Kerberos, was a monstrous 3-headed dog that guarded the gates of the underworld, preventing the living from entering and the dead from escaping. The 3 heads represent the 3 primary functions or principles of the Kerberos authentication system. The first head represents the client or the user trying to access a service or resource. This is the entity that requests access and presents its credentials, username, and password to the authentication system. The second head represents the server or the service or resource that the client wants to access. This is the entity that needs to verify the client's identity and ensure that the client is authorized to access the requested service or resource. The third head represents the Key Distribution Center, KDC, which is the central authority in the Kerberos system. The KDC acts as a trusted intermediary between the client and the server, issuing tickets, like temporary passwords, that prove the client's identity and grant access to the requested service or resource. The 3 heads work together to ensure secure authentication and access control. The client presents its credentials to the KDC, first head. The KDC verifies the credentials and issues a ticket, third head. And the client then presents the ticket to the server, second head, to gain access to the requested service or resource. Just like the mythological Cerberus guarded the gates of the underworld, the 3-headed dog logo symbolizes the way Kerberos guards access to resources within a network or system, ensuring that only authorized users can enter and access them securely.
I think the most accurate answer is for ChatGPT, but let me make a little bit of a verification. If we go to Perplexity AI, and let's see if you ask it the same question. I really like also Perplexity when it comes to accuracy of information. So let's ask it the same question here concerning what does this represent, or the logo represent. Copy, okay, and then paste here. Let's ask and open the Pro version. Okay, okay, but here is he didn't. Okay, yes. Why the purpose? Let me give it a little bit of a notification. Uh, why? Okay, the Kerberos Microsoft protocol, Kerberos protocol. Okay, let's see the answer. Okay, didn't answer or give me a clear answer. But anyway, I think